Finally getting some time to sleep. Oh, such a nice bed. I miss my bed. Alright. My favorite time of the day. I need to close the lights, turn off the lights. No, I don't need to. Okay. Shh. Wait. I forgot maths. Hello! Let's talk about the Pythagoras Theorem. Let's talk about the Pythagoras Theorem. Let's talk about the Pythagoras Theorem. The Pythagoras Let's get into it. Before we do anything, let me tell you a joke. What did the right Before we get into anything, let me tell you guys a joke. What did the right triangle say to the isosceles triangle? Looking a little bit obtuse. Let's just get into it. Right. Look at this picture. There's a man. He's walking in a path. So, why is he taking that path? Right. Why did he take a shortcut? Well, the answer, of course, because it's a shortcut. Well, why? On top of why? Well, if we draw a line from one point to another point here, you can get a triangle. And not just any triangle, a right triangle. See, there's a thing called distance and displacement. This is distance. Takes 2 steps. Displacement takes only 1 step. See this guy here? He's Pythagoras.
Yes!
He made the statement that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. Look at this triangle, ABC. Add squares, and you get D squares of side A, B, C. You get A squared, B squared, and C squared. Let's try a little game. 3 centimeters, 4 centimeters, and an unknown side. So by Pythagoras Theorem, A squared plus B squared is equal to C squared. So you get 3 squared plus 4 squared is equal to what? 9 plus 16, 25, square root both sides, and you get 5. So therefore, the missing side, the hypotenuse, is 5 centimeters. So why am I talking about this? Well, it relates to ratio. Therefore, since these sides are comparable, they are in a ratio of 3 to 4 to 5. What I mean by that is that whatever you time or multiply these numbers by, the value will always be the same. So let's say 2, you can get 6, 8, and 10. Or you can even divide them. So let's say you divide 10, get 0.3, 0.4, and also 0.5. But why? Why? Why is that the reason? Well, let's take this triangle, add them. Let's take this triangle and then duplicate them. We rotate, rotate, and rotate. And then we make a figure of 4 triangles. Well, yeah, as you can see, these triangles are sides A, B, C. And then find the area. Area of triangle is base times height over 2. So you get AB over 2. And then since there are 4 of these identical ones, you get 4 times that, so you get 4AB squared, 4AB over 2. And then within these triangles, you have a big square. Well, the area of square is of course side times side, so you get C squared. Nothing hard. And then for this part, it is a big figure, an entire figure. It is also another square, the triangles and the square inside. So it's a big square with side A plus B. So the area is A plus B times A plus B, and you get A squared plus 2AB plus B squared. So the last step is that you add all of these up. And then you can get this equation. You solve the equation, 2ab plus c squared is equals to a squared plus 2ab plus b squared. You cancel the 2ab out from both sides, and voila, you get c squared is equals to a squared plus b squared.